ladies and gentlemen, it is my pleasure to introduce the next speaker. If you guys could put your hands together for Rob Seiwert.
Thank you, everyone. How you doing today? That's great. I'm Rob Seiwert. I'm a IT director for Video Corporation America out in Central Jersey. We're a mid-market company providing engineering solutions. I actually am going to be speaking today, visualization and alerting in Nagios. We actually use XI, so a lot of my examples will be XI, but if you're a core user, it's okay. Most of this stuff is PNP for Nagios. Great little plugin. Version .6 is supported on core. If you're running XI, you're running .4. Anyway, I'm a new Nagios user, relatively new. I've been used Big Brother almost up, I was trying to figure out the date, probably 2010. The old Big Brother, better than free license. And I was using Big Brother before version 1. I was using MRTG back then, before RRD. So then we started moving forward. RRD has been around for a while. It's not the end-all, be-all solution, but it's what we have. It's what we're using. If you're using XI, you're using it, even if you don't know it. So all this stuff is there. So I had a real-world problem, basically, and we'll come down. This is one of my real-world problems. I thought, to me, it's yeah, we don't have display. No, I don't think I did.
Yeah, it's moving over here on this unit.
So it's on the screen right now. So I do have a real-world problem. And HDMI to the rescue.
Try it again. No. Yeah.
That cable is loose. How about now?
Okay. Nope.
Okay, let's do this real quick. Sorry, we have technical difficulties. I might have to restart my presentation too after this, I bet.
Here we're swapping to clone. Sorry.
Yeah, the first slide came up.
How's that?
No, it thinks it's in.
Yeah, we're up now.
Most excellent. Yay. So here's my real world problem. It struck me, typically that yellow line's my alerting line. And it always seems, maybe about 6:30 on a Friday night, we're crossing that warning threshold. And to tell you the truth, my hard drive hitting 85% is not scaring me. I'm going home, I'm going out, I'm going to the bar. 2 a.m., I'm coming home after getting chilly. And all of a sudden, we're at critical. It's like, ah. And it struck me that days earlier, I could have known about this. So here's another standard XI graph. This doesn't really look so horrible, does it? This wouldn't scare you. But in actuality, here we go. We're a week before, we were at 8.5 terabytes. We're at 11 terabytes now in a week on something that generally doesn't grow. So I said, hey, I need a better way to see this. I need better alerting. What is out there? So there's Holt Winters forecasting in our RRD. The real problem is you have to be set up for it before you can even use it. If you don't have those aggregations already defined in your checks, you're not getting it. So the next one that seems to make sense would be trend. There's another part of RRD. It's something you can do. You can say, hey, give me a trend. That's really a sliding scale. So it doesn't necessarily give you exactly what you need. Predict, same thing, a little more complicated. And then the last thing is the least squares line, or if you know RRD, the LSL. So I'm like, after a little research, I'm like, okay, we're gonna use the least squares line. It's very simple, it's very straightforward, it's linear data. This is the kind of thing we wanna see. And if you go out there and you search the web, it turns out a lot of people have done this already. This is out there, how you do it's out there. It's not new. I mean, that first one on the left was done in 07. So, 7 years ago. 09, 011, 011. Okay, so the thing is, how do I get it into Nagios now? People have done it here, they produce these JS, but it's not happening in Nagios. So the first thing we go into is PNP, and we say, how do I make this? You build templates is what you do, and there's a templates.dist and a, if you run xi, it's local user Nagios share PNP templates. Now, templates.dist you shouldn't be touching, but in the end you might. Templates.share is where you're supposed to put your stuff. That way it's not overwritten. And the way it works, it basically says if you have a service called HTTP and the host name is localhost, it's going to go look in the templates directory for, or it's going to look, not in the templates directory, it's going to go look in the perf data directory, which is also in share under Nagios. And this is like the metadata for your check. It says, hey, what the min was, what the max is for the check, what template it's going to use, what check generated this. So like if you're checking for HTTP, it's going to go look for check HTTP in the templates directory, then it's going to look in the templates.dist for the default one for that service. And then if it doesn't find anything that matches, it's going to use the default template. Now, if you want to change the way your graphs look in Nagios across the board, you change the default template. On a side note now, like I said, templates.dist you shouldn't touch. If you run xi, the default's pulled from templates.dist always, and it ignores the one in templates. If you run PNP, other way around. Okay, this is an example of the metadata. It tells you what the last actual was, what units are being used, what the data source name is. All this information is available to you in the template. Now, the real thing with these, so we go in and we're going to start building a template, right? It's PHP, first of all. Now, I don't know PHP, but if you've programmed it all, it's simple enough, it's straightforward. All you're really doing is building a string. The other thing is, I don't know if anyone knows how to use RRD tool, but it's basically you're building the RRD tool statement in the template. So I started off trying to emulate some of those checks I found on the web. First thing that's worth to point out is in your options, these are the options that are passed to RRD, you need to open up your date range into the future. So, so right here, we just say n now plus 7 days. So now we have opened up a graph from 7 days in the past to 7 days in the future. Now, this is actually another one of my critical systems. You can kind of see it was riding at 80% for forever. And you don't even notice it, but 80% on a 16 terabyte disk array, when you start hitting 90, you're not very far away. Well, you are very far away, but you still have a big problem. And actually, this is the one that I was looking at growing by terabytes in a week. And so this n plus 7 represents this size, start n minus 7 days. Of course, this graph does not match this definition. Sorry about that. Problem is now all my data, now that things aren't critical, is very boring. I had to go back to previous versions to find interesting pictures. But then now we get to the meat of it all. We have the data set. So again, RRD tool, great documentation online, actively supported. I'm sure there'll be something new. There's all kinds of new products, but it's what we have, it's what we use, and it's what we're using by default. So the first one is, this is a standard definition. This is the line that you see right here, quite literally. It's the real data. Down here, turn around and say, hey, give me the same data set. Just now, instead of all the data, just give me a day's worth of data. Give me 2 days worth of data. Give me 7 days worth of data. So now I have some defs for What's a def? Well, I'm glad you asked. The definition is actually the data set in your RRD tool. I didn't explain. RRD tool is a tool that takes the raw data and then aggregates it up and stores it for you, the round-robin database. And what's cool about the round-robin database is before that, we'd have logs, and you'd parse logs upon logs upon logs to get your trend. And they would grow, and you'd have to do log rotations, and you'd have to purge them over time. The RRD database, once you've defined it, never grows. You decide how much data you want to keep, at what resolution you want to keep it at, hours, days, weeks. Do I want to keep, a week average for 10 years? You can, but that's never going to get larger. So that's the actual data, is the def, the data set, as I'll probably refer to it. Following that is a CDEF. A CDEF is a def that is built in memory, and typically it's based off some calculation, some reverse Polish notation calculation. And then down here we also have a VDEF. A VDEF is more of a value. It's a single point. It has a piece of data. It also has a piece of time associated, or a time associated with it. But you can think of it just basically as a number. So we're going to talk about reverse Polish notation. I don't know. If you're old school, you know this. You know this very well. If you're younger, you go, what's that? Reverse Polish notation sometimes is called postfix, as opposed to what we normally write, which is referred to as infix. And it's where you put the operation, reverse Polish notation, the operators follow their operands. For instance, to add 3 and 4, you'd write 3, 4, and you do the operation plus. The real beauty is you don't need parentheses ever in reverse Polish notation. The other thing that's kind of core to it, it's very simple to work with in terms of computers. In fact, in the beginning, everything was RPN, because you'd push this number onto the stack, you'd push that number onto the stack, you'd do the operation and push that back onto the stack. Anyway. Yeah, obviates the need for parentheses that are required by infix. So, in what I'm showing you now, I decided to use percentages. That was a mistake, by the way, but I just went with it. It's what I did. So I turn around here. This is where I actually take the actual definition here and turn around. So first of all, remember I pulled in 4 data sets. The regular data set, the data set for 1 day, 2 days, and 7 days. And now I'm turning them all into percentages, just using reverse Polish notation. Here's what I actually used. Multiply it up, or multiply it by 100, push down the capacity of the unit, and then divide. So again, this is still all in the template that you're building. And the template, that's what this stuff in the front, it's just you're building an array in PHP. So you got to turn around, and the dot equals is additive to the array, if you don't know. So now we get down to the meat of it. So I want to say, hey, what is the slope of data set 2? And that's very simply, again, it's a number. It's going to be a fixed number. And this is one of the things RRD tool gives you is many operations in your RPN, like first, last, limit, and then, of course, trend, predict, and slope. Now, LSL is the least square slope. We'll get into that in a little bit. You also have the LSL int, which is the y-intercept, the LSL correlation, the Pearson's product momentum correlation number, which is actually a very cool metric. A lot of people don't understand it. We'll get into that in a minute. So now I actually have the information for making the line. But we have to turn around and actually make the line for RRD, because these are just numbers. So CDEF is another consolidated data range that's created in memory. The first thing we have to do is we have to get a time sequence into a CDEF. By default, it doesn't have one. If you're not working with time data already, so we turn around and we push this value on, and we immediately pop it off the stack. This is, again, another one of the operations for RPN. And so now we have nothing on the stack, but we have time associated with our CDEF. We turn around, we push D2, which in this one is the slope, the count, another operation. This is the number of, this is the count of steps, is what you're pretty much getting. So here we pushed a time rate in here, so now we're getting, actually this isn't a total count of steps, this is the count of the step you are on in the data range. I know it's getting kind of thick real fast. So in your first pixel, the count's going to be 1. On your second pixel, the count's going to be 2, 3, 4, 5. And then we have to turn around. So now what have we got? We got D2, we got the slope, we got the position that it's in, we multiply it, or we take the slope, multiply by the count, and then add in the y-intercept. And there's some more stuff here. I just want to go back to a picture. So essentially, over here, this would be count 0, and we've got the slope coming up, and we're adding it back in. And that's what's actually creating this line. This is the CDEF that we just talked about. So this little line here is the, in this case, I think this might have been a 4-hour trend. And that data is, that line is what's created by this line right here. So then at the same time, over here we say, okay, now I didn't like that the lines went off the top of the chart. And on my charts, it caused my charts to expand and blow up. And so I said, don't show me anything over 100%, because if my disk is running at 110%, I'm in serious trouble. You know, I wish they could, tell you the truth. Oversubscribe them, right? Then over here, so that's I just limited this trend down just so it didn't screw up the chart. Over here, I say, show me the danger zone. So each of these 3 data sets, 2, 3, and 4, each have a danger zone, if you will. And then show me the point at which the danger zone starts, using the first, and the point. So if I'm crossing from 90 to 100, my line's between 90 and 100. Here's the first point, here's the last point. What else did I say here? The fourth line creates a trend line. Each CDEF must have a time reference. Oh yeah, that's that trick here. This one got me, because I didn't realize you had to do this. Logically, you don't have to do this. It should, but you do. So that's a trick. You always just, if you're making a CDEF and you're not dealing with data, if you don't already have a time series data line in there, push one on there and then pop it off, and now your CDEF has a time base. Yeah, and basically line 4, again, builds the equation. So I didn't actually talk about the equation so much, but you remember y equals mx plus b? M is the slope, b is the y-intercept, y is the line we're looking for. So you repeat this, and this is where we get. So now we need to add some lines. And so we got an area here that shows a disk usage and a nice black line on the top of it. That's what line 1 and 2 does. Line 1 here is the trend last week, and it's actually trend last week would be this one, causes this line. And do I have the same picture on? Yeah, thanks. And also then we turn around and we put the danger lines in. So here's our danger zone, right? So we do an area for the danger zone for each one of these. And that's how we get these little blocks where it's crossing 90. And then this is just a cool thing. If you get sick and tired of the red and yellow lines, you can turn around and do, this just drops a line at 90% and then stacks a pink line on top of it and a darker pink line on top of that, which I thought, you know, because sometimes you get that, the little yellow and red lines sometimes are not totally clear. If you know what I'm talking about, if you're looking at your charts and you use the critical lines, you're used to the standard stuff. The standard stuff in XI. If you run PNP for Nagios, it's also the standard stuff. If you have no charting and graphing in Nagios right now, first thing you need to do, go out and get PNP. There's better, don't get me wrong, there's better solutions, but this is the most common solution people use out there from my experience. Everyone's trying to build something new and better. I just need something that works. Okay. Down here, this slide really want to push out, you can print out data in an RRD, this :S time shows you the date and time. Now over here in the last 24 hours, we weren't crossing threshold. So this is actually the date and time of a NAN, being that I'm 4 hours off of GMT or UTC or whatever. I'm always 4 hours before midnight on 1970. So this is more my current setup. You can see, like I said, very boring. It doesn't, what's the point of this? But back when I was actually fighting the disk churn issue that was eating up terabytes of data in a week, you could actually see these lines jumping up and down as I found this problem or cleaned up this or just dumped snapshots to make more space. And you could be sitting there and see these lines quite literally moving. I could be watching TV and I could see it over there on my screen updating, and the line, you can see it going up, you can see it going down. A 4-hour trend is not very useful unless you're actively troubleshooting the issue and you want to see immediately what's going on. So generally, this is what I run though: week, 2 days, and 4 days, and these are the lines for such. And then, okay, so I started off, in my template, I actually took the time range and then I flipped it as well. So depending on what view you're using, it got bigger or larger, and I tried pushing out 4 weeks so I could see my line going out 4 weeks. This is what you're tempted to do. But at the same time, because you're aggregating your data, and as you get your chart bigger, you're losing resolution, you're getting a more linear result right out the bat. You're losing resolution to your data. And most of the times, if you're using RRD, you really don't have that much core resolution, because it's designed, I can't think of the numbers out of the box, but it's aggregating up fairly quickly. So we got a few other things in here. It doesn't mean as much because of, well, actually, no, this one it does, because I changed it from percentage. On my second chart, my first chart was percentage-based. And I have the slope and the correlation down here, but these numbers don't mean a hell of a lot. Minus 11, so that would be 0.01 as a slope. Because we're dealing with percentages, you're dealing with really, really tiny numbers. They don't speak to you in English. So in my template, I built a second graph that uses the real numbers. And here, the slope makes a lot more sense here. And we have also figured out how to get the step. I got the base, which is the y-intercept, and the correlation. So we'll talk about these numbers more in a second. But at the same time, I can see right now, or not right now because this isn't live, we're growing at 649 megabytes every 10 minutes. That's a very, you can tell, quite literally, the rate of change on my disk drives, or whatever you have trended. And that's actually something I've been looking for a long time. It struck me, probably a decade ago, I should have the rate of change on my drive. I don't, it's great when they cross 90%, but 90% is not the same. I have a 20 megabyte drive. I have a 2 terabyte drive. 10%, or that 15% warning, is radically different. So this slide's a little out of order. I thought it was before. But the not a number, I always laugh, because whenever I'm not crossing the line, the threshold's set for New Year's Eve 1970, where we had Santana and the Airplane playing at the Fillmore, coming on stage. So every time I see 4 hours before midnight 1970, this is what I think of. But, so I thought I had the solution there. I had a pretty chart. When there was trouble, it was going up, it was flashing. But I have more, well, that was actually on my main SAN, so that was worth watching on a dashboard. But I probably have 1,000 other disk drives that I can't all have on the dashboard at a time. And it struck me that unless I want to sit there and look at that dashboard for the rest of my life, this is not the answer. Plus, it only showed me what was immediately coming in in that week. So I'm a week out. So if it wasn't within the week, I can see it was going up, but it wasn't doing the danger zones. So I did have my chart, and it looked pretty cool. But it seemed to me it could be better. What I need is an alert. I don't need a chart. A chart's great for seeing what's happening. A chart's great for doing, but unless you got someone that you're paying to sit there to watch dashboards, and if I only had one disk drive, that'd be great, but walls and walls and walls of dashboards, this is not the answer. So it struck me, when I did this, I kind of was copying off someone else's work. I didn't quite understand what LSL was all about or how it worked. So when you go into RRD and you get the slope, the M, is the slope relating to the count position of the data. LSN is the y-intercept. LSS correlation is the correlation coefficient. And down here in my chart, you can see where we're using those. So what is the slope? Well, slope is very basically rise over run. It describes the direction and the steepness of the rate of change. It's M in that formula right here, this fourth grade algebra. I had a lot of trouble with that. I had to ask my son. Anyway, what is the y-intercept? Well, that's pretty much just where the line begins. It's your starting point. And what's the correlation coefficient? This actually is very cool, because I don't know if you pulled this number and you notice there, it goes from 1 to -1. Yeah, that first line, the linear correlation between data set and the resultant slope. In other words, it tells you how closely your data is matching the line that you predict. It represents the quality of fit for the approximation. Like I said, it goes from +1 to -1. If your slope is going up, it's going to be above 0. If your slope's going down, it's going to be negative. And 0, if you have a 0 correlation, your line it basically says your line is worthless, because your data is all over the place. With a disk drive, you're probably not going to get a 0 correlation, but some other services you might. So you can look at this, you can look at your trend, but then you say, what's the correlation? You know, hey, it says that we're going to run out of disk space on this day, but what's the correlation? How true is that data? If it's 0.97, it's probably fairly accurate. If it's 0.2, that means it means things are going up and down. There's a lot of thrashing. And I found this very interesting. There's a couple of good lines. The P, Pearson product momentum coefficient, or the correlation coefficient. So we got -1. We have a tight match going downwards. We got +1. We got a tight match going upwards. When it's equal to 0, your data is all over the place. I found an even better picture that shows the various things. You know, here's loose data, -1, 1, 0. One thing that's important to note, if your slope is 0, the correlation coefficient is going to be not a number, because it's not defined for a non-slope. So every now and then you'll see NaN, which means you got a flat line anyway. So it's not a big problem. So knowing, again, when I started this, I was doing it in a percentage, and that was a mistake because it doesn't give you real data in your step. But if you know what the maximum value is, whether it's 13 terabytes or 100% or whatever unit you're working on, you should be able to solve this equation. Again, I had to go to my son, little fourth grade algebra, and it turns out y equals mx plus b when you know what, y at 100%, and you know what the slope is, and you know what the intercept is, you can solve for x. What is x? You would think so. You would think so. You think x would be the answer, but x is not the answer. X is the number of steps in an RRD tool. So the question really becomes, what is the step size that you're using? And if you use RRD tool, You know, the step size is very arbitrary. You can tell it, I want to use this step size. You can go onto the data set, and I say, I want to use this step size. But on the RRD forums, they say, well, that, as long as you don't put it on a graph, that's fine. But it seems like no matter what you do, it turns around and then says, well, really, a step's going to be as big as a pixel, because a step can never be smaller than a pixel. So if you're representing 6 months worth of data, your step size, or a month worth of data, your step size is going to be like 10,800, I think. And it's going to be big. So the question is, and you want a smaller step size to start with, because you want valid data. You don't want aggregated data to begin with. So the real trick actually was figuring out what is the actual step size. And you can force this a number of ways. Initially on my check, I just forced it by doing the math and then making a graph of that size. So if I'm looking for 2 days worth of trending, my graph is 3,600 pixels big. Not that I'm ever going to display that, but it forces it. Anyway, so I'm curious, how many people is this Greek to? How many people have used RRD tool before? There you go. How many people have actually coded their own RRD tool checks? Okay, so this actually is not even bash, born again shell type scripting. It's just good old bourne shell scripting. This just says execute this statement and put what comes out of it into this variable. This is just the RRD tool command, and we can go through it step by step, but it's more the same. Here's your data source. We're going back 2 days. We're forcing this step to some number, but again, that's not necessarily true. Over here, a big enough width to make sure that it is true. We get our slope. We get our y-intercept. We get our correlation coefficient. We calculate here. I should put more notes in here. What do we calculate here? Count. Oh, okay. This is a count. This is the count of. So we get a count, and then we turn around. We also create a time series here. We get the beginning and the end of the time series. Then we do math, where we actually take the starting time. And this is over here, so we turn around, we put time series in here. We put the max time in there. We put the minimum time in there. We subtract the two, so we know the total time range. And Cmax is probably defined here as the maximum of count, yes. And so, it's not zero-based. So we subtract 1 from the count. So we get an actual number of steps, and we divide by that. And now we actually have the actual step size, which is great. Now, it always strikes me, I haven't had time to rewrite RRT tool or fork it out and do this, but it'd be very simple to turn around and just make yet another RPN notation, because this data is in the data structure in RRD tool, the step size. So instead of actually running this series and doing this, this math actually occurs over the whole time series just to get one number. Yeah, RDT will just actually release a new version where they actually can now calculate single values. But before 149, don't ask me a specific version, until just recently, if you wanted to do math, you had to do it in a time series. So there's a huge amount of calculations that go on here to get this number that really could be short-circuited out into, hey, just tell me what the step is, please. And I figure it out here mostly because I don't trust this number up here. I verified that it is the same in this case, but calculate it. So then I turn around and just print all this stuff out. Boom, 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 boom. And in the end, it's in a variable called result. And then it gets very simple. We turn around, we set result, which splits all those values into their various things. So I have $2, $3, $4. The biggest trick is they have this comment because it's hard to keep track of what $5 is later on. A little data for the check. And what do we got here? So we start assuming everything's okay. The status is what's going to be returned in the exit code back to Nagios. And Okay, so we turn around and we can say, hey, we're going to reach 100% at this date and time. There's also another check in the check that says, hey, it's downward, your trend's downward, you're not going to cross it. I don't have that. This is cut and paste. It doesn't show you everything. So then we calculate the time to reach. So we can actually say, hey, why do I have to calculate? Oh yeah, minus now, of course. Okay, so date-d turns your seconds into human readable dates. We have our slope times our step, and we also know what our correlation coefficient is. But the whole point was to alert on this. So now we come around and we say, hey, how many days is it going to be till this happens? That's what time till. If we're less than 30 days, do a warning. If we're less than 2 days, go critical. Okay, so in the end, this is the end result on my SAN. This is actually from last night. I'm going to hit 100% at June 22nd, 2015. And now this number will change. In fact, for the last several weeks, I've been on a downward trend, which is great. But then, you go away and people start getting crazy, and next thing you know, things are popping up. Now, this also gives you a graph that's kind of a little hard to, if you're just used to looking at linear. I mean, if you're like me before you had this, you turned around and you looked at your chart, and then you kind of put your hand up to it. Let's see, where is that going to, it's right about there. And then you're like, where is that? So this is actually a graph of the rate of change on the disk array. So you can see that before I came here, it was negative. So we were growing at some point at 20 megs a minute. Last night, we were growing about 20 megs a minute. Oh, actually, now this graph, by the way, has a different side. So the other thing I did, by the way, this is my default template for everything. So every one of my charts looks like this. It has a, you're used to last, max, and min, and average, but I also have the slope on everything. I have the step I'm looking at, and the base. So this is my default, what my default template looks like. So this is nothing special, actually, for me. This is what a template looks like. This is just raw performance data. But the fact that I can tell how fast my disk array is growing or shrinking, and I should also say, this is a SAN, this is a disk in an equalogic pool. Equalogic's actually very interesting. I'd like to say, hey, I could give you this check and you can run it, but you can't, because a pool is an arbitrary virtual concept. So you got members, you got pools, you got groups. I'm sorry, this is the whole group. But the same check works for all three of them. But because the sizing is virtual, I can turn around and assign this member to this pool or this member to that pool, or take this member and put it in another group. All of a sudden, instead of being 13 terabytes, it could be 40 terabytes. So we use the capacity as a second data set, which would be normally, if you looked at the default charts, would be just a flat line all the time until you changed it. But that's actually used in the percentage calculation. So I actually have to grab data set 1 and data set 2 and marry them together. Okay, so what did I learned? This again came out of a real world problem. I was sitting here fighting the problem, and I was kind of upset that I wasn't alerted to my Oracle log file drive filling up quickly, or my SAN about to run out of space quickly, and how fast they were changing without me being notified that the rate of change was well beyond expected norms. So the first thing you learn, though, is the step size is not what you think. Just because you told RRD this is your step size, that is not your step size. Don't believe it. Verify it, either using the trick I just showed you. The resolution will affect your results. So I first built that pretty chart. I thought I was done. I was watching my chart, working on my problems. But then I said, you know what? I can push this chart out 2 months. And I can see where my trend is going in 2 months. But at the same, because you're making your step size so big, and then you're looking at averages, you end up with not valid data. You get very nice, the correlation coefficient's really high and everything else, because now you're looking at the average for a day, not the average for every 5 minutes. So data resolution will affect results. This drives me nuts. The guy who wrote the EqualLogic plugin decided to put extra data in, but it didn't follow, the extra data was snapshot size and this and that, where warn and crit and min and max should have been. And to tell you the truth, when I flipped over to 2014 XI and was running the high charts, it actually choked. You know, it killed high charts, because high charts thought that metadata was what it should be. And some plugin author decided it should be something else. So if you're writing plugins, please, if there's a min, if you know the warn, if you know the crit, if you know the min, if you know the max, put them in. I know me, I just want the performance data. I don't need any of that. Put them in, it's useful. I didn't show you a slide of this, but one of the things I also found out when I was doing this, and I've seen it before, but I'd never solved it, is I started using RRD scaling to the SI units, which makes a lot of sense. But so then you end up with like 300K gigabytes or 300 mil gigabytes. You know, put the bytes is the unit. And actually in RRD, if you don't specify a unit, K means 1,000. If you do put the unit of B, K is 1024. I mean, that's a choice for you, but definitely work using the SI units. I mentioned the default templates. One other final thing here. I don't know how many times you've gone to go look, and all of a sudden you look at your charts and they're all nans because something changed. There's a thing, there's a check right there in XI or in PNP, in PNP as well, called check PNP RRD, which will tell you when your data is not being recorded. I'd make it a standard check if I were you, if you're using PNP or XI. What else we got here? Just as we talked about this, be sure to set those values if you're writing a plugin. SI units, I was like, what the heck is SI units? It's French, the International System of Units. It's a metric thing. You got to kind of learn these things because you'll see the micro. That's exactly, so many micro terabytes. You know, I don't know what a micro, I have to do the math. And it's, you know, if you worked in bytes, you wouldn't end up with a report that said, you know, 23 micro terabytes. And I think that wraps it up. Are there any questions? Yes. Wait.
So are these charts actually, I assume that they're integrated into what you see in Nagios. So how did you apply the template?
Well, actually, if you run XI, you actually can do it in the admin menu. But to apply the template's just a name matching thing. So it's based off the name of your check. And don't be confused about the name of your test and the name of your check. So it's the check command name.
So your RRD template is the same as the check command name?
Yes, yes.
Okay.
All the way in the back.
When you were first calculating your LSL slope, at the beginning you were doing -7 days and +7 days. What happens when you view that on a 4-hour scale or a 24-hour scale or a week scale?
All those are valid, and you'll get different results, obviously. And it's a question of what you want to see. So I'd actually built it for 1 day, 2 days, and 7 days. But then I started working immediately on the problem, you know, cutting away this, some virtual drive got skinified, you know, freeing up the oversubscription and coming back. And I wanted to see my trends more immediately. So I turned around and just changed, I think, one of them to a 4-hour scale, which you saw in one of the earlier slides. So I could see what I was working on that day more immediately, what kind of effect it had on the overall trend. When you move to beyond a week, unless you've set up your RRD definitions, to include more data, you're going to get aggregation and you're going to start losing resolution. And you'll get different results. See, that's what surprised me. I could look at the same data range, and just by even pushing the chart out, and changing my step size, I was getting different results, and I could get one result or another result. So resolution is important. Any other questions?
This does seem like a great fit for disk monitoring. Have you used this principle, applied it to monitoring other things? I mean, I think memory would be a reasonable
Yeah, well, like I
idea.
said, one of these checks is my default graph. Oh, this check hasn't been, no. But this is my default chart, so I always have slope and scale. And if I go to a 4-hour scale, I'm at a minute already for step, just out of the box. So I can just quite literally read that number and say, hey, this is my rate of change for the last 4 hours in my default. Now, have I rewritten the alert check? No, in fact, my next step is, I explained to you the disk array had a virtual capacity, so I have to marry data sets, so it's kind of a custom check for the EqualLogix disk array right now. My next step is to generalize it for all my disks. And you're right, memory is another good one. Just about anything, really. Now, don't get me wrong, Holt-Winters forecasting is probably a better way to go because you can actually do seasonal type. So if you're looking at bandwidth, for example, I mean, if you've watched your bandwidth charts, Monday through Friday, it goes like this, right? And then Saturday and Sunday, it's like this, then Monday. Those are seasons. So Holt-Winters forecasting is actually seasonal forecasting. So you can say, you know, at noon on a weekday, this is normal but you know, if you see, it gives you a variable alerting. So you could go further with that. This is purely for linear style data. You know, but yeah, slope is still slope and it's still valid. But certain things lend to the slope on my bandwidth utilization may not alert properly. Anyone else?
All right, if you guys put your hands together for Rob Seiwert one more time, we appreciate it, Rob. Thank you so much.
No, thank you.